Alright, this is the 2003 no calculator multiple choice test that I'm going to go over so you can look at it at your own pace. Alright, so let's just jump in here. Number one, we're finding the derivative, and we have an inside function. The inside function is x cubed plus 1, and the outside function is 2. So when we have an inside and outside, we use the chain rule. So we're going to start with the power, bring down the power, 2 times, leave the inside alone, decrease the power, so that would be to the first power, multiplied by the derivative of the inside, which is 3x squared, and when we clean that up, we'll get 6x squared times x cubed plus 1, which is letter E. Number two, we're finding the antiderivative. This is not what I would call a normal integration. It is a u substitution, and we let u equal to the power. So u is equal to negative 4x. du is equal to negative 4 dx, and we don't need that negative 4, so we're going to divide it out on both sides. When we do the u substitution, we will get the integration of e to the u with a negative 1/4 out front, and that would translate back into, well, let's go ahead and integrate it. That would give me negative 1/4 e to the u, and so that would translate back into, when I put it in terms of x, negative 1/4 e to the negative 4x evaluated from 0 to 1. So that would be negative 1/4. When I substitute 1, I get e to the negative 4th, and when I substitute 0, e to the 0 is 1. So that would be minus 1/4, and so that would be letter, what are we looking at here? Did I make an error somewhere? Yep, right here when I did minus, that should be minus negative 1/4, which would be plus, which would be letter D. Be careful of those arithmetic errors. Don't be going too fast. Number three is an interesting question. It says I have, for x is greater than 0, to the right of 0, the horizontal line, y equal to 2, is an asymptote for some mystery function. So here is the horizontal line, y equal to 2, and to the right of 0, that is an asymptote, and it says which of the following statements must be true. Well, something that some students didn't know or had forgotten about is the fact that when a function can cross its horizontal asymptote, a function never crosses its vertical. So a function will not cross a vertical asymptote, but it can, it doesn't have to, it can cross a horizontal asymptote. In other words, this function, that whatever it is, could at some point come across the horizontal asymptote, but the guarantee is that as the function approaches infinity, the function will approach its horizontal asymptote, but again, it can cross the horizontal asymptote. Alright, so which of the following must be true? Well, this says when x is 0, y is 2. There's no evidence of that, so that does not have to be true. Letter B says y is never equal to 2. Well, we just talked about the fact that the function could cross its horizontal asymptote, so there could be a y value of 2, but there doesn't have to be a y value of 2. So that's out. Number 3, f of 2 is defined. Well, it could be true, but it doesn't have to be true. Letter D, the limit as x approaches 2 of f of x approaches infinity. That's not true, but we do know, as we stated earlier, that as the end behavior, as x approaches infinity, the function will approach its horizontal asymptote of 2. Number 4. Number 4 is asking us to find the derivative, and we're going to find the derivative by the quotient rule. Letter E has to be out, because if we do down d up minus up d down over down down, we're going to have 3x plus 2 quantity squared. So we'll have down d up minus up d down over down, down. And once you clean up your numerator, you're just going to simply get negative 5 over 3x if you do your algebra correctly, which is letter D. Number 5, it is a normal an integration problem. When we find the antiderivative of sine, we get negative cosine. Remember to check your antidifferentiation by taking the derivative to make sure you have it correct, from 0 to pi over 4. So that would be negative cosine of pi over 4 minus negative cosine of 0. The cosine of pi over 4 is root 2 over 2, and that becomes a plus. The cosine of 0 is 1, so we get 1 minus root 2 over 2, or negative root 2 over 2 plus 1, which is letter D. All right, number 6, we're looking at a limit as x approaches infinity. As x approaches infinity, this is end behavior, and a rational function, will always approach its horizontal asymptote at the ends. So we're looking at the degree in the numerator. The degree in the numerator is 3. The degree in the denominator is 3. So when a rational function has the same degree in the numerator and denominator, the horizontal asymptote is the quotient of the leading coefficient. So the quotient of x cubed is, or the coefficient of x cubed is 1 in the numerator, the coefficient of x cubed is 4 in the denominator. So we're approaching a horizontal asymptote, or a y value of 1/4 as we approach infinity. Number 7, they give us the graph of the derivative. So this is f prime. Which of the following statements is true about f? F is decreasing from negative 1 to 1. Well, if I look at negative 1 to 1, over in this region, the first derivative is positive, so the original function would be increasing, and in this region, the slopes are negative, so the original function would be decreasing. Okay, again, study your All About Me sheet. So that is incorrect. B, f is increasing from negative 2 to 0. All right, if I if I look at the function from negative 2 to 0, the first derivative in that entire region is positive, telling me that the original function is increasing, so that is a true statement. And so that is our answer for number 7. Number 8, we're finding an antiderivative. It is a product, and when you're finding the antiderivative of a product, you're going to go with u substitution. I'm going to let u be the inside of the cosine, which would be x cubed. du is 3x squared. I don't need the 3, so I'm going to divide it on both sides, and that's dx. I'm going to make my replacement, and I'll get the cosine of u with a 1/3 out front, du. The antiderivative of cosine is sine, so I get 1/3 sine u plus c. I'm going to make my replacement back. U is equal to x cubed, so I get 1/3 sine x cubed plus c, which is letter B. Number 9, they ask us to find the derivative at 0. It is an ln, and the derivative of ln is u prime over u. So when I take u prime, I'll get 1. The derivative of x is 1. The derivative of 4 is 0. The derivative of e to a power is e to the power times the derivative of the power. So I get negative 3e to the negative 3x. So that's u prime over u, x, plus 4 plus e to the negative 3x. And now I'm going to evaluate that at 0. So I'm substituting 0 in place of x. So I have 1. If I put 0 in here, e to the 0 is 1. So that's 1 minus 3. In the denominator, I'll put a 0 here, plus 4. Again, e to the 0 is 1. 4 plus 1 is 5. Do the arithmetic, and I get negative 2/5, which is letter A. Number 10. the function f has the property that f, or the original function, the first derivative, and the second derivative are all negative. In other words, that's telling me that each of these three graphs is below the x-axis. Which of the following could be the graph of f? Well, let's think about this. First of all, if f is negative, that means the graph is below the x-axis. So we can eliminate one answer just by looking at that. If the first derivative is negative, that means that f of x is decreasing. Well, in A, we can see that this function is increasing at this point, so that one is out. B is decreasing everywhere. C is increasing everywhere, so that's out. And D is also decreasing. All right, so we've narrowed it down. The second derivative being negative tells me that f of x is concave down. This is the all about me sheet. This function is concave down, this function is down and then up, so the answer has to be B. It's very important that you know all the facts of the all about me sheet and how they work together. Okay, number 11. This is the problem that I warned you about on a number of occasions. They don't want you to find the antiderivative. They want you to figure out which of the following is the same problem in terms of u. And they start off by telling you that u is equal to 2x plus 1. All right, so let's look at this. If u is equal to 2x plus 1, then du is equal to 2 dx. And I don't need that 2, so I'm going to get it over to the other side. So I can go ahead and eliminate answer D and E because I can see that I'm going to have a 1/2 in my answer. When I make the substitution, I'll get 1/2 of the integral of u to the 1/2 power du. Now, which is the square root of u. And all of these fit, so the only question is, what about the bounds? Now, this is very, very important. Remember, we talked about this before, that these numbers right here, 0 and 2, are x numbers because that integral is in terms of x. So it is our job to take those x numbers in here and turn them into u numbers. So if I substitute -2 in place of x, 2 times -2 is -4. -4 plus 1 is -3. So that -2 becomes a -3. And then something just went wrong there. Hold on. Okay, I see what happened. That's not a -2, that's a +2 up here. When I circled it, it looked like a negative. So when I substitute 2 times 2 is 4, plus 1 is 5. Sorry about that. And then when I substitute 0 in place of x, 2 times 0 is 0, plus 1 is 1. So this is what's really going to decide it. It's changing those x bounds into u bounds, so be very careful with that. Number 12 is your friend because it's direct translation. So look carefully or listen carefully to how I translate this. The rate of change of volume. So I start out by translating rate of change of volume is dV dt of water in a tank with respect to time. Okay, so that confirms that it should be dt. Here's the word is equal directly proportional to. Now remember, direct proportion is a multiplication problem. And it's like y varies directly as x. It's the same thing. Y is directly proportional to x. So you're going to have that constant of proportionality. But in this case, it says that the rate of change of volume, dV dt, is directly, there's my constant of proportionality, directly proportional to the square root of volume. So it's just straight translation, which is letter E. Number 13, the graph of an original function. This is f of x. An original function is shown. At which value of x is the function continuous but not differentiable? Well, that's pretty easy. There's a discontinuity here, but you can't take the derivative. There's a discontinuity here, you can't take the derivative. But the function is continuous here at that sharp turn, but you can't take the derivative. So that's a freebie, and number 13 is A. Number 14, they ask us to find the derivative. Please be careful. It is a product. So we have the first times the derivative of the second. We're going to use the chain rule here. The derivative of sine is cosine of the angle multiplied by the derivative of the angle. And the derivative of the angle is 2. Okay, so that was first plus, times the derivative of the second plus the second, which is sine 2x times the derivative of the first. Now you'll notice their answer, they did some factoring, so you have to also do some factoring. All right, now look carefully at what we have in common. There's a 2 here and an x squared. There should be oh, you know what I didn't do? I didn't correctly take the derivative. So this is the second times the derivative of the first. So this should be 2x. Sorry about that. So I have a 2 and an x squared, and over here I have a 2x. So the greatest common factor that I can take out of that is a 2x. Now when I take a 2x out of the first term, it'll get rid of that 2, and it'll get rid of one of the x's, and leaving me with x cosine 2x. When I take 2x out of the second term, I get sine of 2x. So number 14 is E. Okay, and evidently in this flip chart I'd done these problems before and I didn't get rid of the work in number 15, so I'll just go ahead and talk about it instead of doing the work again. In number 15, let f be the function with the derivative given by. So they've given us the derivative here. On which of the following intervals is f decreasing? Well, the first thing I'm going to need to do is to set my derivative equal to 0 to get critical numbers. And when I do that, notice that I added 2 over x to both sides in this step right here. So I added 2 over x to both sides. Then I'm going to cross multiply, and so that gives me x cubed is equal to 2. I'm going to take the cube root of both sides, and I get 1. Now also I have another critical number. You know what, let me just redo this problem just so you can see the whole thing. I'll just get rid of all that. Alright, so let's start again. We're going to take the first derivative, x squared minus 2 over x, and I'm going to set it equal to 0. And I'm going to do this a little bit differently this time. What I would do here is get a common denominator, and the common denominator is x. So I'm going to multiply the first expression by x and get x cubed, and I don't need to multiply the second expression by anything. Now when you're finding your critical numbers, what students often forget is that a critical number is any value of x that makes the first derivative either 0 or the first derivative undefined. So in this case, the number that would make the first derivative 0 is what I get when I get x cubed minus 2 equal to 0. X cubed is equal to 2. So x is equal to the cube root of 2. Also, 0 would make the denominator or make this fraction go undefined, so another critical number is x equal to 0. So I'm going to put those guys on my number line. So I have 0 and I have the cube root of 2. Now the cube root of 2 is 1 point something, so when I test a number, I'm going to choose the number 1. This is a first derivative number line, and so I'm plugging into the first derivative. So if I plug, let's say, -1 in place of, if I put -1 here, I'll get, if I'm using this derivative, if I put in -1, I'll get +1 minus 2 over -1, that would become +2, so that's a positive. So the function is increasing, but we're looking for decreasing. If I substitute the number 1 in here, I'll get 1 minus 2, which is negative 1, so I get a negative. So the function is decreasing. And if I pick a number bigger than the cube root of 2, like 5, that would give me 25 minus 2 over 5, which is positive. So the original function is increasing. So we are decreasing from 0 to the cube root of 2, which is letter D. Number 16, if the line tangent to the graph of f. Now this is important, ladies and gentlemen. The line is tangent to f at the point 1, 7, and that same line passes through this point. So what they've given me here is they're talking about a line, and they've given me 2 points on the line. Now what's important is that this is a tangent line, and they're asking me the derivative at 1. Well, the definition of a tangent line, or not the tangent line, but the slope of my tangent line is the derivative at the point of tangency. That's exactly what a derivative is. It's the slope of the tangent line at a point. So if I can find the slope of this tangent line, then I'll know the derivative at 1. Well, that's very easy. They gave me 2 points. We know that slope is change in y over change in x. So if I find the slope of this line, then I'll know the derivative at 1. So if I do change in y, I'll have negative 2 minus 7 over negative 2 minus 1. That would be negative 9 over negative 3, which is 3, which is letter C. Number 17, f is a function given. The graph is concave down. All about me sheet. To get concave down interval, I'm guessing that this chart goes with the next problem. To get a concave down interval, I need the second derivative. So the first derivative, by the product rule, please be careful, is the first times the derivative of the second plus the second times the derivative of the first. And again, that was by the product rule. The second derivative, which is what I'm really after here, is, okay, this term uses the product rule, this term does not. So I have first derivative second plus second derivative of the first plus the derivative of this term would be just 2e to the x. Before I do anything, I'm going to combine my like terms here, and I get 4e to the x. All right, now I need to set the second derivative equal to 0. So to get my possible points of inflection, I'm going to factor out 2e to the x, which leaves me with x plus 2. I'm going to set each factor equal to 0, but remember, I cannot raise e to any power and get 0. E to the first power is e. E to the 0 power is 1. E to a negative power simply makes a fraction. So this can never be 0, so nothing comes out of that factor. But I get x plus 2 equal to 0, so x equal to negative 2 is a possible point of inflection. All right, now we're looking for concave down interval, so I'm going to make a second derivative number line. I'm putting negative 2 on the number line. I'm going to choose a number to the left like negative 3, and I'm going to plug that in to the factored form of my derivative, of my second derivative. So if I put in, we already said that 2e to the x will always be positive, so we don't really have to worry about that. When I put a negative 3 in here, I'll get a negative output, so negative, concave down. Now let's check the other side to make sure. When I pick a number greater than negative 2, like 0, again, this is always positive. This factor would be positive, so I get a positive, and the graph is concave up. So my concave down interval is to the left of 2, which is letter A, left of negative 2. All right, number 18, the derivative G prime of a function g is continuous, very important. Has exactly 2 zeros, so it crosses the x-axis twice. Selected values of g prime are given in the table above. Hang on a second, I'm going to move that table to this page right here. Okay, so now that I have the table on this page, we can answer the question. Selected values of the first derivative are given in the table above, or above in this case. If the domain of g is a set of all real numbers, then g is increasing on which of the following intervals? Well, the first thing I notice is that the first derivative is equal to 0 at -2, and the first derivative is equal to 0 at +2. I notice that the outputs for the first derivative here are positive, function increasing, negative, function decreasing, and then positive, original function increasing, because remember these are first derivative, so the original function is decreasing on A. Number 19, the words. Remember, the key to your success is being able to get these words. A curve has slope. That's like saying a curve has a derivative. It's not like, that's what it's saying. A curve has a derivative of 2x plus 3 at each point xy. Which of the following is an equation for this curve? In other words, they want the original. They're giving you the derivative and they want you to go to the original. So how do you go from a derivative to an original? You find the antiderivative. All right, now the other thing that they're giving us is a way to find the value of c. So we're going to find the antiderivative of 2x plus 3 dx. That gives me 2x squared over 2 plus 3x plus c. That would be my original function. And now I need to solve for the value of c, so I have a value of y is 2 when x is 1. So I have 2 is equal to 1 squared plus 3 times 1 plus c. So I have 2 is equal to 1 plus 3 plus c. So that would be c is equal to -2. So the original function is x squared plus 3x minus 2, which is d. That's a very easy question, but students can get stuck on the words. Careful translation. Slope of a curve is the derivative. Find the curve, the original. So to go, if you have a derivative and you want the original, you have to find the antiderivative. Number 20. Which of the following statements is true? We have a piecewise function, and it says, first of all, does the limit exist? Well, if I substitute 3 in place of x in the first piece, 3 plus 2 is 5, and that is a closed circle. When I substitute 3 in place of x, 4 times 3 is 12. 12 minus 7 is 5. So that is an open circle. Now the other thing that you can do, certainly to be pretty safe here, is just simply graph this. So we know that we just said that we have the points 1, 2, 3, 1, 2, 3, 4, 5. All right, that point is in common on both lines because these are simply lines. We have the line x plus 2 to the left of 3, so I have a y-intercept of 2. I can plot that point, and that's what that piece of the function looks like. And then on the other side, I can get another point for 4x minus 7. I've already plugged in 3. Let's plug in 4. 4 times 4 is 16, and 16 take away 7 is 9. So I have 4, 5, 6, 7, 8, 9. Something like that. So I have two lines that are coming together there. So does the limit exist? It absolutely does. That is true. What number is this? 20. Is the function continuous at 3? Yeah, there's no hole there because we filled the hole, so that's true. Is the function differentiable at 3? No, there is a sharp turn. The left derivative over here on this side, let's go ahead and revisit that concept. The left derivative, so the limit as x approaches 3 of the f prime of x, the left derivative is equal to 1 because the slope of that line is equal to 1, which is not the same as the limit as x approaches 3 of the first derivative of x on the right-hand side, which is 4. So the left derivative and the right derivative are not agreeing with each other. So our answer for number 20 is D. All right, I'm getting close here. Number 21, the second derivative of f is given by, okay, so we have a graph of that. So they give us a generic function and they also give us the graph of the second derivative. For what values of x does the graph have a point of inflection? A point of inflection occurs where the second derivative changes sign. Point of inflection is where the second derivative changes sign. Not just touches, but changes sign. So the second derivative changes signs at a, it changes sign at 0, but it only touches at b. It does not change signs. So the answer for number 21 is A, 0, and A only. 22, the graph of the first derivative is given of f is the line. We want f of 0. Or no, f of 0 is 5. We want f of 1. Ladies and gentlemen, this is an initial condition. Think about it. What do we know? We know f prime. We know the derivative. So let's think about that. We know the derivative. What do we want? We want the original. Why do we want the original? Because we need f of 1 and f is the original. How do you go from the derivative to the original? You find the antiderivative of the original. So what they're really asking me here is find the area from 0 to 1 of f prime of x dx. I got to go backwards. I have to go from the derivative, but I have an initial condition of 5. Remember? That's where that initial condition comes in. So if I collect the area, this is a simple triangle. This is 1 by 6. So 6 times 1 is 6, and half of 6 is 3. The area in this region right here is 3. So the antiderivative from 0 to 1 of the derivative is 3, plus the 5, the initial condition, gives me 8. Again, it's decoding the problem and trying to figure out what do they really want me to figure out? What are they really asking me to do? So just take a minute to study this problem and make sure you understand it. Number 23, our favorite problem of all. We're finding the derivative of a definite integral. When we're finding the derivative of the definite integral, we take out the t. Okay, so I take the inside function, I take out the t. Step number 2, put in the new function. The new function is x squared, so I'm going to put the x squared where I took out the t. Step number 3, multiply by the derivative of the new function. This is the new function, and the derivative of x squared is 2x. So we're looking for 2x sine x to the 6, because when you simplify that, 2x is out front, sine, and when you have a power to a power, you multiply the powers, and you get x to the 6, which is letter E. 24. Let f be the function defined by which of the following is an equation of the line tangent to the graph where x equals 1. This is a very straightforward problem. To get the y value, we have an x value, we need the y value, so we're going to substitute into the original function. And so when you do that, f of 1 is going to be 4. Then I need the derivative at 1 in order to get the slope. So the derivative of this function would be 12x squared minus 5. And the derivative evaluated at 1, if you do the arithmetic, is 7. So now I have the slope. And since these equations are in y equal mx plus b form, that's how I'm going to write my equation. I need to find the y-intercept, so I have 4 equal to 7 times negative 1 plus b. When I solve for b by adding 7 to both sides, I get 11. I can see quickly that my y-intercept is 11, and so there's my answer. Number 25, a particle moves along the x-axis. so that its position is given. When is the particle at rest? Particle at rest when the velocity is 0. So I'm going to find the velocity of this function by taking the derivative. So I get 6t squared minus 42t plus 72. I'm going to set that equal to 0. I'm going to divide everything by 6 and get t squared minus 7t plus 12. I'm going to factor that. T, 3, 4, minus, minus. So t equal 3. T equal 4 is when the particle is at rest, which is letter E. 26. What is the slope of the line tangent to the curve at this point? We have x's and y's, so it's implicit differentiation. So when I find the derivative, I get 6y dy dx minus 4x is equal to 0 minus product rule. I'm going to leave the 2 out front, so I'll have first derivative second plus second times the derivative of the first. Now you could have taken the negative 2, stuck it with the x, and carried it through like that. When I clean up, I'll get 6y dy dx minus 4x is equal to negative 2x dy dx minus 2y. I'm going to get all the dy dx's on one side, so I'll have 2x. I'm adding it to the left-hand side, and 6y, and I'm factoring out the dy dx. So again, I added the 2x dy dx to the left-hand side, and I went ahead and factored out my dy dx. I'm going to move the 4x to the right-hand side by addition, so I have 4x minus 2y. So dy dx would be what I get when I divide. So actually, I don't even need to take it that far because I'm substituting in the 0.32. So I'm going to substitute 3 everywhere that I have an x. So I'll substitute 3 here, substitute 3 here. I'm going to substitute y or 2 everywhere that I have a y. So I'm going to substitute 2 here, substitute 2 here. Solve for dy dx. And if you carefully do the arithmetic, you will get 4/9, which is B. 27. In 27, we have inverse functions. And so we have the original function f of x, and g of x is the inverse of that. Remember that the derivative of partner points on inverse functions are reciprocals of each other. Now this is worth going back. There's a lesson on this on my YouTube page. There is a sheet of notes in your notebook that review this. So we have, remember we used to make the little charts, and we would have f the original and f inverse, which is the same thing as g. On the g function, or the inverse function, we have the point 2, 1, meaning that on the original function we have the point 1, 2. Okay, so now we're going to find the derivative. Now we know that f of x is given, so the derivative of f of x is 3x squared plus 1. So I can find the derivative of f at 1, which would be 3 plus 1 is 4. So the derivative of 1 at 4, the derivative of 1 at 1 is 4. So the derivative of his inverse would be the reciprocal of that, which would be 1/4. So that is definitely worth going back and looking at your notes, because it's really not that hard. You just have to be careful and make the chart. All right, so this would be, again, f prime, and this would be over here g prime. Is that the last question, or is there one more? Let's see. I thought there was one more question. Okay, evidently there is number 28, but for some reason I don't have it in this flip chart. I will tell you that the answer to number 28 is E, and if you need some help on that, come in and see me, but evidently I don't have that problem. So I hope you find this video helpful. Watch it as often as you need to.